Good evening, ma'am.
Good evening, ma'am.
Yeah. In today's session, we are going to discuss the Week 9 PPA.
Good evening, ma'am.
Okay, ma'am.
Mm, Ma'am, I have a doubt regarding one of the marking system of the graded question.
Yeah.
Ma'am, in the week 8 graded question, there's a question
Yeah.
which have 0 points assigned to it.
0 points assigned to it.
Yes, ma'am.
In which week?
Week 8 question number. Week 8 question. Let me see that. Week 6 question number 6.
Week 8, question number 6. Let me check. Yeah. Maybe by mistake. Let me verify with the team.
Okay.
So the Week 9, it covers on dynamic programming, dynamic memory allocation, so let us see the first question. So we are given an employee structure. So employee structure is given like a linked list, employee linked list. Okay. So the employee structure contains employee name and salary and a pointer to the next employee information. So it is something like a linked list. Say for example, okay. So you can have a, so each employee having three fields. The first field indicate the name of the employee. Say for example, we have an employee 1, EMP1, so employee 1 and his salary, say 10,000. And here you will have the address of the next node. Okay, here we'll have the address of the next employee information. Okay, so like this, so this is employee 2, EMP2, and say salary of 20,000. And this is also having a link to the next employee information. This will have a link to the next employee information. So like that, the last employee will have the address as a null. So here what we are doing, we are creating an employee linker list. So first employee and his salary, and this will be the address of the next where the next employee record is stored. So generally when we create an array, we will know, if you know the first employee address, then you can able to find out where will be the data of the second employee and where will be the data of the third employee using an indexing. Whereas when you create like a linker list, okay, so you cannot guarantee that all the data is in contiguous memory. Say this is the first employee information which is stored in one, say suppose 2000 location. This is the second employee information which is stored in a different location. Next employee information may be stored in a different address location. Say, so in this case, after the first employee will have an address of the second employee record, and the second employee record will have an address of the third employee record. Like that, the last employee will have the address as a null, so that there is no next employee information. So we'll store it like a linker list here. Okay, so employee name and salary, and this is a pointer, next is a pointer pointing to the same type of structure element. So this is a structure of a linker list. We call this as a self-referential structure. So we are given a self-referential structure. So employee information, employee name, salary, and the next. So last employee will have a address as a null. So here we are given a function to read the input in the format, read the employee name and salary separated by space, and add structure to the list end. So when a new employee is read, he will be added to the end of the linker list. Okay, suppose if I have already 2 employee information, now I want to create another new employee. So that employee record will be added to the end of the list, end of this linker list. And read choice as an integer. If it inputs 1, go to the step 1 again and read the next employee data. If the input is 0, stop and print all employee names that have a maximum salary. So like this you are given. So you are reading the first employee information. So you are asking the choice whether to continue or not. So if your choice is 1, we will read the next employee information. Again 1, read the next employee. So like that, if your choice is 0, then stop. And we need to print the employees whose salary is maximum. So among this, the employee 1, employee 3, employee 4 salaries are maximum. All are having a same value. So same maximum. So in case of the employee, more than 1 employee with the maximum salary, print all the employee names in the same order they are inserted into. So first we have inserted employee 1. So first employee 1 information is displayed, then employee 3, then employee 4, because these 3 are having the maximum salary. So more than 1 employee is having the maximum salary. So we have to display them in the order of their insertion order. So first we have inserted employee 1, then 3, then 4. So in that order we need to display. So that is the problem. Okay. So we are reading the employee name and salary, and we are asking for the choice. If the choice is 1, we need to read the next employee information and store it at the end of the linked list. Like that, we need to read till your choice is 0. So if your choice is 0, put the address of the next employee as null, store the null in the next field of the employee, and then display the employee information whose salary is maximum. If there are more than one employee having the maximum salary, display them in the order of their insertion. Okay, so that is the problem given to you. Okay, now we'll see the solution. So we are already given some of the code. So this is the structure of the employee. This is the structure of the employee. In the main, just we are calling a employee list. So you are going to create a linked list of employee. So this is the code we are going to write. So here what we need to find out, along with the employee information, we need to find out who is having a maximum salary. So the maximum salary I am storing into a variable called max. Initially, the max value is taken as 0. And we are creating a linked list. We are creating 3 employee type variables, pointers, actually not variables. These are the pointers. So pointer to the employee structure. Okay, so first, temp and head. There are 3 pointers that were created. So first always pointing. So the first will be pointing to the first record. To this record, we will point the first. Okay. So to this, the first is pointing. So first is pointing to this. And temp is pointing to the last node. Always we will see that the first pointer is pointing to the address of the first node, and temp is pointing to the last node. Always. Okay. So whereas a head is used as a temporary variable. While accessing the data, we will take the data into the head and then we'll move one by one record. So temp is the last and first is the first employee information. So we will take this address. If you want to know the second employee, you can say first next. So this field is called name. This field is called salary. This field is called next, because here the employee structure is given as like that. Okay. So there are 3 fields in your structure. The first is the name, second one is a salary, and the third one is next. So the next will have, if you say first next, you will get the address of this. First equal to first next means your first will move to this particular record. And again first equal first next means it will go to this record. So like that it will move. Okay. So we have created 3 pointers. Initially their value is null. They are not pointing to any employee. Okay. So we have taken a choice variable and we are writing a do while loop. So in that what we so when it is a pointer, when you declare a pointer, your system will not allocate the memory. So we need to allocate using dynamic memory allocation functions. One of the dynamic memory allocation function is malloc. Malloc will memory allocation will allocate the required size. So how much memory is required to store one employee information? So because this is a structure, so how much memory it will require is sum of the memory required by each individual field in that. So name requires 50 characters, salary require 4 bytes, name require 50 bytes, salary require 4 bytes. So, and this address is also, it will occupy some memory. So the total memory required by this structure variable, that much memory we will allocate to the, yes, we are creating a pointer, one pointer variable to the employee structure. So to this structure so this pointer variable, we are allocating the memory. So LOC is the function. How much memory we need to allocate? We need to give it in bytes. So if you don't know how much memory will be occupied by this structure variable in your system, you can simply use size of. Size of will give you the number of bytes occupied by your operand in the memory. So size of struct employee. That means employee, you are finding an employee record size. That much memory you are allocating. So in that memory, what you are storing a pointer to an employee structure. So you are whenever you use a malloc function, it will create a void type memory. It will create void type memory where you can't store nothing. You are going to store nothing. Void means nothing. Okay. So we need to convert that memory to an employee pointer memory, so that in that memory you can able to store the name, salary, and address of the next employee. So to void type memory will be converted to this employee structure type pointer, and that you are allocating to yes. So what happens when you execute this statement is, so it will create an empty node. Okay, so it will create an empty node like this. Okay, so it will create an empty node like this with the 3 parts in it. Okay, it will allocate the memory like this. Now we need to fill each of the part. We need to fill the, suppose if the name of this, we are taking it as yes. Yes is the name of this. Okay, the name of this particular cell that was created, memory that was created is yes. Now we need to fill the this part. This is called yes. Because it is a pointer, we will access the pointer using arrow. So this is yes, the yes arrow name, and this is yes arrow salary. This is yes arrow next fields. Okay, these are the corresponding fields. This is this box is a yes arrow name. This is a salary. This is the next. So first we have allocated, and it will create an empty node like this. Okay, first it has created an empty node like this. So now initially we stored first as a null. So if first is equal to null, we are making first is equal to yes and temp equal. So first equal to null means there are no nodes in the linker list. There are no nodes in the linker list. So we will make this as the first node. So this is the first, as well as this is also a last. So last is nothing but we are calling it as temp. So this is the first node and this is the temp node. Both are this only. Okay. When if first equal to null, because first equal to null indicate that there are no previous nodes. Else means already there are some nodes. In that case, what we need, so suppose already we have a employee 1 and employee 2. Now we are going to create a new node. Okay, new node. So this is our yes. So then what happens if this is our yes? Now this is the last node that we are going to insert now. So we need to make always the last node is to be pointed by temp. So we will store temp equal to yes. And we need to link this to the previous node. So the previous node is now temp. So temp next equal to yes and temp equal to yes. So what we'll do here, temp next equal to yes means it will link this node to this node, newly created node. and this last node will become the temp. So if already there are some nodes, we will do this. If there are no nodes, that will be the first and that will be the last. Okay. So like this, now after assigning the correct pointers to the nodes, we will read the name and salary of the employee. So name is a string and the salary is a integer. So we are reading the name and salary of the employee. And also we are reading the choice, because we whether to continue or so. Now till now we have read one employee information. We have allocated memory for storing one employee. Okay, and then we have assigned that, we have inserted that node in the proper place in the linked list by using this code, and now we are assigning the name and salary to that employee. Okay, now, and that means we have filled these columns, the name value, salary value we have filled, and always the next, because we are inserting at the end, so always the next field will have a null value. We'll store it in the null. So now, if now we need to maintain the maximum salary in a variable called max. Okay, so that's why I am comparing the max value with the salary that we have read now. If max is if your salary is more than the max, we are changing the max value, so that always the max variable will contain the maximum salary. Okay, and we are reading the choice. If your choice is good, we are repeating this loop, do while loop. We are repeating this do while loop till choice is equal to 1. Okay, so that means if choice is 1, then again it will allocate the memory for the next employee, and then it will insert the node in proper place in the linked list, and again read the name and salary, and calculate the max value. So this this is a loop, do while loop. It is a do while loop. So it will repeat this loop as long as our choice is 1. So when our choice is other than 1, it might be 0 or something. Okay, so then it will come out of this loop, and then it will assign the, because we stopped the linked list, the last node is pointed by temp, and the temp next value we are storing a null. After the last employee, there is no address, no other node. So the address field of the last one, you are storing null. Okay, now our aim is we need to print all the employees whose salary is maximum. So now for that, we have taken a head, one temporary node called head. In that we are storing the address of the first node. So while head not equal to null, we are moving the head one after another. Each node, node by node, we are moving. And how long we need to move the head till we reach to the null? Okay, if its address is not null, then it will do the processing. It will check whether max value is equal to head salary or not. So initially, the head is pointing to this. So the max salary, let us consider 20,000 is the max value. So it will check. So this is my head now. So the head salary is 10,000, max value is 20,000. So whether these two are equal or not, it will check. If it is equal, it will print the name of that head node. So it is not equal. So what happened? Head equal to head next. So that it will head, your head will move to the second node. And again, it will check whether max is equal to the salary of this head node. Yes, then it will print the name of that head node. Okay, so in that way, the code, so if max equal to head salary, it will print the head name. Okay, and then we are moving the head to the next node. So this will be repeated, this code, like comparing your max with the salary of the node. And if it is equal to max, you are printing the head name. and then we are moving the head to the next. How long we will do it? Till the head becomes null. When the head becomes null, it will come out of this loop. Okay. So our target is reached. We have displayed all the nodes whose salary is maximum. Okay. So any doubt in this? Just we are creating a linked list. Because it is a pointer, we need to allocate the memory using dynamic memory allocation functions, MLOC. So first we will allocate the memory to the node, and after allocating, we will attach that node in the proper place in the linked list. If already nodes are there, we will attach to the last node. If there are no nodes, we will make this the created node is as the first and last. Okay, each time we are moving the last to the newly created node. Okay, and then we are filling the fields of this node. We are reading the name and salary. So like that we'll do it till your choice is 1. When choice is other than 1, we will stop and store the null value at the end, last node. Okay, and again what we are doing, we are taking the first node, we are starting from the first node and checking whether this is the maximum, this is the maximum. Like if the node salary value is maximum, we are displaying the name of that node. Okay, so that is the code. So any doubt in this? Hello, am I audible, ma?
Yes, ma'am.
Okay.
No doubt.
Yes, ma'am.
Okay. Then we will move to the second problem. So the second problem is, write a function named two-dimensional array, which takes 2 integers as input, row and column, and return a double pointer. The function declares a double pointer and dynamically allocate a memory for two-dimensional array of size row by column. The function then initializes all the elements of 2D array to 0. Okay. So your input is how many rows and columns you have in the matrix, two-dimensional matrix. Okay, two-dimensional array is nothing but a matrix. We call it as a matrix. Okay, so how many rows and columns are there? We will read it. So and initialize those rows and columns with 0. All the rows and columns with 0 and display that. There are 2 rows. This is the first row and this is the second row. Initialize all the values of that row and column as 0. Okay. So you are asked to return you are asked to write a function. This is the function name. 2dim array is the function name. So that function will take 2 integers as input, row value, column value. It is taking row and column as input, and it is returning double pointer. Okay, so it is returning a double pointer. Double pointer means how we will take like that. Yes, so let us. Okay, so think that there are 4 rows and 3 columns. So this is the first row, and this is the second row, and this is the third row. So there are 3 rows, 4 rows. Let us consider there are 4 rows and 3 columns. Okay, so this is row 1, this is row 2. So let us say R1, R2 like that. Okay, so let me call this as R1, row 1, row 2, row 3, row 4. And this will be column 1, column 2, column 3. Okay. So that row and column value intersection is this. This is the value. So you need to fill all the, say, the row and column are given as an input to you. You need to fill all these values with the 0. Okay. So how we will do it? Double pointer is nothing but, say here, we are considering this as one pointer. R1 is one pointer. Pointing to the, see, a single pointer, you can treat it like a single dimensional array. So int star p means, suppose if you write int star p means, that says that you can create a single dimensional array with this. Okay. So R1 is a one single dimensional array. So R1 is a pointer to the first row, one single dimensional array. R2 is a pointer to the second single dimensional array. R3 is a pointer to the third single dimensional array. So R4 is a pointer to the fourth dimensional array. So 2D array is nothing but set of 1D arrays. 2D array is nothing but set of 1D arrays. Each 1D array is represented using one pointer. So this will be a set of pointers. You can say this is a array of pointers. You can also set of values. We call it as an array. So this is a set of pointers, or we can also call it as a array of pointers. So we need to create an array of pointers. One pointer means one star. Array of pointer means you can represent it using double star. So this indicates that pointer to pointer. Okay, one single pointer is one dimensional array. So if you add one more star to that, a pointer to that, that means it is a array of pointers. Again, array of pointers. So we will have 4 pointers here. Like how many rows we have, those many number of pointers. So this whole matrix will be a pointer to a pointer. So double pointer, that we call it as a double pointer. Okay. So it is returning a double pointer. That means it is returning a matrix, a 2D array. So first we need to allocate the memory to your 2D array. So first we need to allocate how many pointers we require. How many pointers we require. It's here. Suppose I need to create this. So how many pointers I require? 4 pointers. One is R1, another is R2, R3, R4. How many pointers? How I will know? My row value. How much is my row value? So my row value is nothing but how many pointers that I need to create. So here we are allocating the memory to row into size of each pointer. Okay. So it will create how many pointers, how many rows are there in your matrix. Those many number of pointers you can store in this memory.
And so what is the meaning of int double star?
Double star, I told you, no, pointer to pointer.
Pointer of, we are taking pointer of some another pointer, like star
Yeah.
p, that pointer.
Pointer to pointers, like array of pointers. You can also call this as a array of pointers. See,
Okay.
like suppose if I say int star p, a single star p. So this is equivalent to one single dimensional array. This is equivalent to one single dimensional array. So here what I'm doing, R1. R1 is a pointer to my first row of 2D array. Okay, R1 is a pointer to the first row of the 2D array. R2 is a pointer to the second row of the 2D array. R3 is a pointer to the third row. Like 2D array.
Okay, so we are taking pointer of that pointer.
Yeah. So 2D array is nothing but a set of 1D arrays. Set of 1D arrays, or you can also call array of 1D arrays. Array of
Okay,
1D
ma'am.
arrays. So 1D array is one star P. Array of 1D array means another like array of pointers, you can say. So another one star is one array. So double star means array of pointers. Okay. So here array of pointer. How many pointers are there? How many rows we have in your 2D array? Those many pointers we will have. How many rows we have in your 2D array? Those many pointers you need to create. Okay. Your array size is like second level array size is how many pointers you need to create. How many pointers we need to create? How many rows are there in your 2D array? Those many pointers we need to create. Okay. So you need to, like, this is, suppose you call it as a M. Your M is nothing but a double pointer. Okay. Array of pointers. Your M is nothing but array of pointers. So one pointer is one star. Array of pointer means double star, double pointer. Okay. So first, what we are doing in our code, first we need to create how many pointers that you need to create. Like first we need to allocate the memory for each pointer. For each pointer. So how many pointers we need to create? How many rows are there in your matrix 2D array? Those, so rows into size of one particular pointer. One pointer means address. So integer pointer only. Address will always be an integer. So how many rows you have? Those many pointers memory you are creating. To store those many pointers, we are creating the memory.
So ma'am, in size of, why we are not writing only int, we are writing int star?
Size, like pointer, you are finding the size of your integer pointer, because R1 is your, like
Okay,
here
basically
R1
integer
is a
star is
pointer.
the complete data type.
Yeah, int star is a pointer. So you are finding the
Okay.
size of your pointer.
Okay.
Okay. So size of the pointer, one pointer, size of one pointer into number of rows. So that will create row number of pointers. So memory will be allocated to store how many rows are there, those many pointers memory will be allocated. And in that memory, what you are storing a double, like a matrix form. So you are converting this whole thing into array of pointers, into star array of pointers, and that you are assigning to a variable ARR. So ARR is a matrix which contains a array of pointers. And each pointer is representing the address of one row. So like that, row number of rows are there. Okay. Now we have allocated memory to those pointers. Now each pointer is again one row. So in that row, how many elements that you are going to store, how many columns are there in your 2D array, those values you need to create. So we need to allocate the memory to store all those values. How many columns we have in each row, those memory locations you need to create. So size of int, so you are going to store an integer. How many integers you are going to store in that row? Into column. Column means if your column value is 3, you are going to store 3 integers. If your column value is 4, you are going to store 4 integers. So size of integer into number of columns. That much memory we are allocating, so that we can store how many elements are there in the column. The total memory will be allocated. There we are going to store, we are converting that into an integer pointer, and we are storing in a array of I. So that means I is nothing but the row, your first pointer, row, 0th row, first row, second row. So like for each row, you are allocating the memory. How much memory you are allocating is how many columns you have that into to store an integer in each column. So that much memory will be allocated to that array. ARR is your array. Okay, so array of I, that means I value is 0, 0th row. You are allocating the memory to the 0th row. If I value is 1, you are allocating the memory to the first row. I value is to second row. Like that, how many rows we have for each and every row we have allocated the memory. Because it is a pointer, system will not allocate the memory. We have to allocate using MAL rows. So by the end of this for loop, you have created one empty matrix. We have created an empty matrix whose name is ARR. Empty matrix or empty two-dimensional array consists of row number of rows, column number of columns. Okay. So now matrix is created and memory is allocated by this type. Now we need to store zeros in those matrix. So how will, like once we allocate the memory, we can refer it like a statistically you can able to refer that. Okay. So I equal to 0, I less than rows, I plus plus, j equal to 0, j less than column, j plus plus, a of ij means ith row, jth column element value, we are going to store it as a 0. So when I equal to 0, it will vary, j value will vary from 0 to column and it will fill the first row. Okay. So initially, like this value is 0. Instead of saying R1, we can say R0. So for this particular row value is 0. For this particular row value is 1. So this will be referred as instead of because our index will always start from 0. Let us name these as 0, 1, 2 like. Okay. So this will be 0, 0, row 0, column 0. In that place, we are going to I value refer to the row, j value refer to the column. When I equal to 0, when I value is equal to 0, j will vary from 0 to 2. So 0, 0, 0, 1. So here j value will be 0. For this j value will be 1. And for this j value will be 2. Okay. So this will be row column combination. 0th row, 0th column. Then j value will increase. 0th row, first column. 0th row, second column. Okay. This will be 0, 1. This will be I value will be 0. J value will be 2. So in your matrix, M of 0, 0, you are storing 0. Next M of 0, 1, you are storing 0. M of 0, 2, you are storing. Like that, it will, j value will vary till your column size. Then I gets incremented now. So I will become 1. Again, j will be starting from 0 to column. So this row will be filled next. This row will be filled next. Like that, I value will go up to row. So this code will fill this code will fill the matrix with the zeros. A of I array of I comma j equal to 0. That means I throw jth column value of that matrix is 0. So I, j are the loop variables. So suppose row value is 3, j value column value is 2 means 3 into 2. 6 times it will assign 0. Okay. And then your task is over. You are returning the ARR value. So return ARR. So ARR is nothing but a double pointer. So it is returning the double pointer. Okay. So that value we are going to display it here. In the main array, we call this. So this has written the ARR value into P. Your P is your created array. Okay. Now you are displaying the P value. You can also say it as P of ij here. So you can also write this as P of ij, or you can in terms of like suppose if A is an array, so you can call, suppose if this is A, you can also call this as A plus 0. This is A plus 1 address of this. This is A plus 2. Okay, so the value at this address means you can say star A. Okay, the value at this you can say star A plus 1. The value at this is star A plus 2, like this. Okay, so this will display the each row. So again, one more star means to indicate the row value. So just in single row, you can display this. This is a single row. And this J, this is the row address. Star of P plus I is the current row address. And to that, you are adding an index J. So J value will be the column. So at this address, and this star indicate the value at this whole address. Okay, when I equal to 0, it will be the address of the first row. This is the address of the first row. Plus J means corresponding column in the first row. Okay, so this whole thing will become now address, and value at that address you use star, so that it will display all the elements in the, when I value is 0, it will display all the elements in the 0th row. When I value is 1, it will display all the values in the first row, second row, like that it will display the matrix. So we have stored zeros in all the rows and columns, so it will display a matrix of size row by column. Okay. So here the logic is how many pointers we need to create, and for each pointer, in each pointer, how many values you are going to store. Like first is how many rows we have, those many pointers we need to create, and for each pointer, how much memory we need to allocate is how many columns we have in the 2D array, those many integers. For storing those many integers, we need to allocate the memory. Okay, this is the main part. Okay, this will create an empty array, and you are assigning, for an array, you are assigning all the values to 0, and you are returning that array. And here you are displaying that array. You can even display this, you can remove this, and you can say P of ij. It will work. Okay, whereas using pointer, we will represent it like that, whereas using even statistically to represent this, once we allocate, we can refer that either dynamically or statistically also, once memory is created. Any doubt in this? Just we have created a 2D array using pointers. 2D array using pointers, and initialize the 2D array with the zeros. Then we'll move to the next problem. So next problem is, write a function named print transpose that takes 3 inputs, a 2D array of integers, number of rows, number of columns. The function displays the transpose of a 2D array given as a parameter. The function does not return anything. Okay. The size of row and column won't exceed 10. Okay. So here you are given, first one is a row value, second one is a column value. So that means there are 2 rows, 1 column. In each row, we have only 1 column. So the next are the values of the matrix. So this is the first row. First row value is 3 because only 1 column. Second row value is 4. So our matrix is 2 rows, 1 column. So you need to find out the transpose of that. Transpose means the rows will become columns, columns will become rows. Okay. Say for example, say I have a 10, 20, 30, 40, 50, 60. So this means there are 3 rows, first row, second row, third row, 3 rows and 2 columns. This is first column, this is the second column. 3 rows, 2 columns. So your transpose will be having, so this is a 3 by 2. We say that this is a matrix of size 3 by 2. 3 by 2 matrices. So when you transpose this, you will get a matrix of 2 by 3. The size of the matrix will be 2 by 3. The transpose matrix, rows will become columns, columns will become rows. Okay, 2 rows. So this will be the first row and then this will be the second row. So the values will be 10, 30, 50. This is the first row. And then 20, 40, 60. This is the second row. Okay. So this is the first row and this is the second row. 2 rows. In each row we have 3 columns. So this is the transpose. So rows becomes columns, columns becomes rows. That is what we are doing. Okay. So always the index I indicate the row. So the I value will vary from 0 to number of rows, whereas J indicate a column, current column. So J value will vary from 0 to number of columns. So I value will vary from 0 to number of rows. J value will vary from 0 to number of columns. Okay. So we are finding the transpose. In the original matrix is A of ij, that is given to you. A of ij is your matrix, and that value, ith row jth column value will be stored in jth row ith column position in the transpose. So that's why here while writing, the row will become j, column will become I. The row will become column, column will become row. So row column element is j, row element is I. So ith row jth element is stored at jth row ith position in ith column in the transpose. So by the end of this loop, it will interchange the values. Rows values will be stored in column, column values will be stored in rows, and that result is in a matrix called transpose. So just to display the transpose value. And while displaying, you check out if original matrix contain R rows and C columns, then transpose matrix will contain C rows and R columns. So display the transpose matrix with C rows and R columns. And when the I value will vary from 0 to number of rows in the transpose is C, opposite. So when j value reaches to r minus 1, that means that particular row is over. So after one row is over, display the slash n, so that next row values will be displayed in the next row. Okay. So just we have transpose, normal transpose only. We did ith row jth column element, we stored at jth row ith column in the transpose. Okay. And then displayed them in the matrix format. Transpose is displayed in the matrix format. Okay. So original matrix, how many rows and columns are there? And we are reading the original matrix that is given to you code, and you are calling a transpose function with the parameters, the original matrix, row and column. So A is an array. So array is A is an array. So array is a starting address of the array. So it will be received like this. Like you can receive it like a 2D array, or you can also receive it like a pointer to pointer also, double pointer. You can receive this like a double pointer also. Okay. So when you are receiving like a static array, always remember you can omit the row size, but compulsory we need to mention the column size. Column size. So here you are given the maximum number of columns will be 10. So we are declaring an array of maximum size. Maybe you are utilizing only a part of it. So that is a disadvantage of static allocation array. Maybe we might be allocating a memory to store 100 elements, but actually we might be making use of only memory of 10 elements. The other 90 elements memory will be wasted. Okay. So any doubt in this? A transpose, simple transpose function. Hello?
Yes, ma'am.
Oh. See the next question. Given a null terminated string, slice the string using 3 parameters: start, number of characters, and step count, and return a new terminated string. Positive index starts from 0, negative value for a start index, negative indexing indicates negative indexing where the last character of the string has index -1. Okay. Negative value for step indicate the string should be traversed from right to left in the reverse order. Okay. So you are given a string. Okay. Say suppose this is your string. H E L L O W, suppose space is there, W O R L D. Suppose this is your string. Think that I have written space, but there is no space between. Okay. So there is no space between hello, the letters of hello and world. So only between this word and this word there is a space. Okay. Now what we were asked is, we are given a starting position. Let us say starting position is 2. So this is 0. Positions are, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are the positions of the letters. Okay. So this is at 0th position. Your string is at the 0th position. First position, second position, third position, fourth position, fifth. Like this is, these are the positions. You are given the start value. So let us think that start value is 2 and the end value is 5. Start value is 2 and the end value is 5. You need to, and suppose let us think that step count is 1. That means you need to display the values from, this is your start and this is your end. You need to display all the values between start and end, with the step count value. Suppose if I say step count equal to 1, that means each and every letter we will equal to 1 means like after displaying this, you display the next value like that. Suppose if your step count equal to 2, that means for every 2 letters you display 1. So this L, if step count is 2, this will be skipped and it will display O. Okay, one letter will be skipped and the next way. Suppose if your step count is 3, two letters will be skipped and the third letter will be displayed. Every third letter will be displayed. Okay, like that. So step count will specify like whether every letter we need to display, or every second letter, or every third letter, or every fourth letter. So how much is the step count value? That letter we will take it, starting from start position till the end position. Okay, so that is the task that you need to complete. And another thing given here is the step count can be negative, and the indexing start position can also be negative. So negative indicate that we are always we are moving from left to right. So if you have a negative value to your start and then step count, that indicate that you are accessing the string from right to left. You are accessing in this direction. So this will have an index of -1. The last letter will have a -1, -2, -3. So negative index will be starting from right to left. This will be -5, -6, -7, -8 till the length of the string you will have -10. Okay, -11. So always the last character will have a index of negative index of -1. So these are the negative indexes. Okay. These are the negative indexes, and these are the positive indexes. Okay. So you are given a start and end positions. You need to take all the characters from starting position till the ending position, and each time you need to increase or decrease your start value by a step count. And once the start reaches to the end, you need to stop, and those position values you need to display. Okay, it is like you are extracting a substring from starting position to the ending position with a given step count value. Okay, that is the problem. So we'll take it here. So you are given hello comma world. So your starting position is 7. Starting position is 7 means H is 0. E means comma will so O will be 4, comma will be 5, W will be 6, O. This O is the 7. Starting position is O in the world. So this is the starting position. From here, you need to display end 2 characters. So the second is n-char. N-char means how many characters from this starting position. You are given an input. The second one is n-char. From this starting position, how many characters you need to display? So 2 characters you need to display. So from here, you need to display 2 characters. So and with the step count of 2. With a step count of 2. So O will be the first character. Step count 2 means it won't display R. Then L will be the second. OL. OL will be the output. These are the 2 characters. Starting from 7th position with a step count 2. Have you understood the problem first? What you need to find out? You need to start at this particular position. These many number of characters you need to extract with this step count. Okay, say for example, if I say start at second position with the step count 3, display 2 characters. So E will be displayed, step count 2 means next 2 will be skipped, and O, EO will be displayed like that. Okay. So while displaying that, you can even use negative indexing. Negative index means you can also start from ending to the beginning. Okay. So your slice string, you need to slice a string. So you are given an input as a start position, number of characters, and a step count value. Okay. So you are calling the slice string function, and this function is returning the sliced string. it is returning the sliced string that you are displaying in the main. So this sliced string, so first we are taking the length of your string. Okay, original string length we are taking, how many characters it is having. If start is less than 0, that means if your start position is a negative, it is given a negative indexing, then your start is equal to length plus start. That means you are moving from back side, you are moving to the original starting position. Okay, so you are even the negative indexing you are converting into positive. Okay, so you are adding length to that. So sliced your first you are you are storing the extracted substring in a variable called sliced. So because sliced is a pointer, you are allocating the memory. How much memory will be required by sliced? You are going to extract and here number of characters is given. These many characters you need to store in sliced string, and so you are allocating that much memory, and number of characters plus 1. This 1 is always, the string will be terminated with a null value. So to store that null value, we require one extra memory, one more byte extra. Suppose if you want to store hello, so hello is having 5 characters, so 5 bytes of memory is enough. But always when you are storing, you want to treat that like a string. String must always terminated with a null value. So at the end you will store null. Null is also a 1 character. So always for the string you need to allocate 1 byte extra than the required length. So in a sliced string, we are storing n characters. So to store the null value, we are adding 1. So we are allocating the memory to store the sliced string. Okay. And then what we are doing, so we are we are starting at the starting position, and each time we are increasing your I by step count value, and from your input ith position character, the character at ith position, you are copying into the sliced jth position. J is starting from 0, so each time j value will be incremented by 1. So first character will be stored at sliced of j, then j will increase its position, then second sliced character is stored in j. So like that, each time j value will be increased. Like how long we need to do like that? Till j reaches to number of characters, or and I value. So the length, suppose if I is positive, we need to do I less than length. If I is negative, that means you are coming from right to left. So I greater than or equal to 0. So your I value must be between 0 to length, between 0th position to the length position only. Okay. And j must be always the number of less than the number of characters. So j will be the length of the sliced string. So its value will be from 0 to sliced string number of characters minus 1. Okay. So that's why we have written how long we need to copy this value at ith position to the sliced string jth position is. So any one of this condition is true. Okay. So whether j reaches to the number of characters, you have to come out, or I value is more than the length, you need to come out, or the I value is greater than or equal to 0, you need to come out in case of backward when you are coming. So in any of these cases, you will come out. By that time, your sliced string will be stored in this variable sliced. So at the end, you need to store the null value to make this sliced as a string. To treat this sliced array as a string, we need to store at the end position. So j is increasing and j is now at empty location. So in that, you store null value and return that sliced string. Okay, so that it will return the from starting position number of characters with the given step count value. Each time here while copying, we are increasing your I by step count. Okay, so how we can like handle the negative indexing is this. If start value less than 0, that means it is negative indexing. So you are starting from length plus start. That means you are converting. So length, suppose it is 5, index is -1. So 5 minus 1 means it will be at the 4th position. So 0 to 4th, that is at the last character. Your first is at last character. Okay, so then each time your if your start is negative, definitely your step count will also be negative. So to your I, you are adding a step count. So suppose step count is -2, you are at 4th position. 4 minus 2 means it will come to the 2nd position. That means you are moving from right side to the left side. Okay, so if you are having a positive indexing, then you will move from your step count will also be positive. You will be, suppose you are at position 1. If your step count is 2, 1 plus 2 means it will move forward. Left to right, it will move. So if it is negative, it will move from right to left. If it is positive, it will move from left to right. So the same code will work for both. Okay, negative and so only thing that you need to do in case of negative indexing is you initially we start at start position, whereas if it is negative indexing, you start at length plus start position. Even the negative indexing you are converting into positive. Okay, so that is the problem. Any doubt? Then we'll move to the next. The next is also same. Whatever the concept that we have discussed now. The only thing is previously we have taken from start position n characters. From starting position n characters we have displayed. This is from starting position to the ending position. With this step count, you need to generate the values. Say, design a C program that reads 3 integers. Previously, we have taken a string. We have sliced the string. Here, we are generating the values, integer values between the given range with the step count. Okay. So, the given range is start, all the values between start to end with the step count. The program should dynamically generate an array containing a range of integers from start to end with the specified step size. Okay. Say for example, your start position is 1, end position is 10. So that means between 1 to 10 with the step count 2, you need to generate all the values, including 1 and 10 also. Okay. So 1 step count 2 means next value will be skipped and the second value will be taken. So 3, 5, 7, 9. So like that till you reach to the 10. So 9, after 9 you will get 11. 11 is more than 10, so it will stop at 9. So by the time it will generate the 5 values, 1, 3, 5, 7, 9. So how many values will be generated between this? You can find out using this formula. Number of elements in this range with this step count. You can, how many values we need to generate, that you can find out using this formula. End minus start by step plus 1. Okay, integer division you need to take. So end value is 10 here. 10 minus 1 means 9. 9 by 2 is 4. 4 plus 1 is 5. So you will be generated with 5 values. So like that, you will be given a range, starting and ending range. How many with a given step count, how many values you can generate is you can find out using end minus start by step count plus 1. So these many number of times you need to repeat the loop by taking I value at start till I reaches to the end. Each time increase your I value by step count. I equal to I plus step. Same how we did in the previous case. Okay. So, but here you see the different implementation. The same logic we are going to implement it using a different implementation. You see it. Because you are given a this like this is a simple code, you can write it in a simple manner, but we are asked to, this is a predefined code given to you. So they have defined an array, new data type def struct array, the structure array, which contains two members. One is array of values and the second is length. Array of values and the length. That means suppose this is your array of values and the length of this is 5. Okay. So your answer you are going to store it in this array. So this array will have array of values and the length of that array. So and this code is also given to you. How it is displayed? So you are passing print array, you are passing an array. So you know that how many values in the array is nothing but a dot length. Suppose a is an array variable, a dot length will give you the length, how many elements are there in that array. So you put a loop which will start at 0 until the length of the array. You are displaying the values of I. So this is an array. A dot values is an array. Ith element of that array you are displaying. I value will vary from 0 to length of that array. Okay, so this is the display. And in the main, we are reading the start and end and a step count value. And we are calling first we are creating a range, and that after creating that range you are storing that in a array variable, array structure. Okay, and that structure variable it is returning, create range function is returning a structure variable, array structure variable, and you are displaying that using by calling the print array function. You are displaying that. Okay, so here how we are creating is, if the step count is 0, we can't generate any value. So we will create an array whose array is a null and length of that array is 0. So this is the return type. Already it is given here. If your array is null, so you return a values pointing to null and length equals to 0. So that is given here. So we are creating a null comma 0 that is converted into array type, and then you are returning that value. Okay. Suppose if step is not equal to 0, then it will come here. First it will find out how many values we need to generate, range value. So the length is equal to this formula, end minus start by step plus 1. Okay, how many elements we need to create, that length value we are calculating. If the calculated length value is less than 0, in that case also we will return the null. If the length value is more than 0, then what we are doing, we are creating an array type structure element. So this type element R, and it is you need to fill values and length. So how many values you need to store in that? What is the size of the length? Those many values you need to create. So you are allocating the memory to store the length number of values. So we have already created the length. So size of integer into length. That means how many integers you are going to store in that array, what might be the length value, those many number of integers you are going to store. So we are allocating the memory where we can store length number of integers. And then the length value is nothing but, so because this R is having two attributes, two fields in that, R dot values, R dot length. R dot values, we are allocating a memory to store length number of values, integers. And in the length, we are storing the length value. Okay. Now we write a for loop. For loop we are writing. So for loop, I is starting at start position, and j is at 0th position. What we are doing in R dot values jth position, you are storing the I value. So that means you are generating the value from I start to end. I is the start position. So I each time you are increasing, like not increasing, increasing by step count value. I each time you are increasing by step count value till I reaches to the end. You store the I value in the values array. So here, so j will be, so initially in the values array 0th position, we store the first value. Each time j gets incremented. So second value will be stored at the first position. Third value will be second position, like that. In the array jth position, we are storing the I value. So I value, we are starting at start position. Each time I is incremented by a step count. So how long we need to do like this is the condition. If step count greater than 0, so that means positive step count. If it is a positive step count, we need to do till I less than or equal to end. If it is if it is a negative step count, then you need to do till I greater than or equal to end. Like you are moving from right to left in case of negative step count. In case of positive step count, you are moving from left to right. So I is moving towards the end in the first case. Step count is greater than 0, whereas I is moving backward. So in that case, so when I greater than or equal to end, you need to stop. Okay. So till this condition is satisfied, it will generate the values from start to the end. All the values from start to the end with the step count value, given step count value, and those values will be stored in values array. So you are returning that array type structure variable. So that it will return it to this R, and you are calling the print array to print the values of that array. Okay. So because here we are allocating the memory using MAL LOC, wherever you allocate the memory using MAL LOC, those memories are to be freed by ourselves. The memory, actually when you use MAL LOC, it will allocate memory dynamically. User will allocate the memory manually. Okay. So if you allocate the memory manually, we are responsible to release that memory, blocked memory. So for releasing that, we use a free function. Free will, MAL LOC will allocate the memory, free will release the memory. So the memory allocated to this array, it will release it. Wherever you use MAL LOC function, there you have to write, once the work is over, the task is over, you need to free it. Okay. So this you can write it even in a simple way, simply one for loop. Okay, I equal to start, I less than or equal to end, I equal to I plus step count to display the I value. So with that simple step you can write, but we are already given a predefined code in the form of a structure type def struct. Struct contains the array and the length of the array. So you have to use this concept while implementing. Okay. Any doubt? So if you don't have any doubt, we will terminate the session. We'll end up the session.